Yeah, that's me. I'm the Developer Relations Officer for NIM. Previously, I was a smart contract developer. I also worked as an artist and a researcher as well. And the title of my section of the talk is going to be Using and Building on NIM, Application and Network Level Privacy for Developers and Cypherpunks. And this is obviously something that I think everyone here kind of knows, but it's worth reiterating quickly before I get into the main architecture and the kind of network components of NIM as they currently stand. And that is that the internet is kind of broken. It was never really designed with privacy in mind. We've had privacy stuff, different privacy things bolted on in reaction to the kind of encroachment on everyone's privacy by nation states and increasingly in the last kind of decade, government companies. But ultimately, you know, there's not an existing solution that can kind of defend against the level of global passive adversary that people like the NSA or Google or Meta kind of represent, especially as soon as we start talking about machine learning enabled kind of data crunching that can be used to start de-anonymizing people. There is a big demand for privacy though. Tor, the fact that Tor has been running, and it has been running for so long, and it has so many users and so much traffic, shows that there is a demand for privacy. And the exponential growth of Signal a few years ago also shows that, as well, as people kind of moved away from WhatsApp, started kind of using Signal on the day-to-day in their phones. However, one of the problems with both of these things is they had an anti-fragile funding model. So they were very donation-based, and Tor itself as a network is not necessarily incentivized. It's people will run it out of the goodness of their own hearts and wanting to have privacy. However, there's no kind of incentivization mechanism for me to run a particularly good Tor exit node, apart from the fact that I want to run a good Tor exit node, which is kind of where our solution then is able to come in. So what NIM is building is a couple of things, with the main focus being a decentralized, incentivized mixnet, which will then provide the kind of network level privacy and especially metadata protection that current solutions currently offer. And then on the application level, we also have a private credentialing scheme, which is called Coconut. And these four things that you see here, the mixnet, the NIM token, the NIM credentials, so the Coconut credentialing scheme, and our blockchain, which is called NIX, just to differentiate it from NIM. Those are the four things that I'm going to move through in the first part of my talk, and then I'm going to talk about how people can actually start using NIM now as developers and as users as well to run application traffic through the mixnet and get the kind of metadata privacy protections that we can offer. So we'll start off with the mixnet. What is a mixnet? A mixnet is basically it's a network overlay. So and what it does is a set of nodes that you can essentially pass traffic through to break the linkability between your kind of sender metadata, so the IP address, the time that maybe you send a request to, whatever, Signal servers or something like this. And the way that it works is that traffic is sent, much like Tor, through multiple hops. So before traffic kind of leaves your NIM client, if you're using NIM, it's multiply encrypted according to the routes through the mixnet that it's going to take, much like onion routing, and it will go through the mixnet in multiple hops. And what this basically means is that each node in that path can only see where packets were coming from, and there's never this linkability between the end server that you might be pinging and you yourself, right? But this kind of already exists. This is something that Tor does. One of the other key features of the mixnet is that we have covered traffic. And so what covered traffic is this is traffic that looks exactly like the actual NIM traffic that you send. Because before, there we go. So it's actually here. So as we can see, right next to the laptop on the left-hand side, your NIM client will always send, it will chop up all of your data packets and encrypt them as Sphinx packets, identically sized Sphinx packets. So each of these Sphinx packets is, at the moment, a kilobyte. And what this basically means is that before traffic even leaves your computer, you can't really start looking at the type of traffic it is, which is something with existing solutions. You can start making inferences about maybe I'm trying to load a video, maybe I'm trying to send an email. right? And what covered traffic allows you to do is, whenever a NIM node comes online, it will also start sending identically sized, identically encrypted Sphinx packets to all other NIM nodes. So you can already see that we have traffic going through multiple hops, so you're breaking sender-receiver linkability. We have cover traffic, so your actual traffic is getting lost in a kind of a crowd of identically sized, identically encrypted packets. And then before each hop that your traffic will take through all of the nodes of the mixnet, which I'll get into in a second with that architecture diagram, there's a variable timing delay that's added as well. So if you start compounding these things, suddenly you have identical looking traffic that's encrypted by the route that it takes through the mixnet. And before each hop, you have this variable timing delay. So it's kind of like sending an identical looking set of cards through the mixnet, holding them for a bit, shuffling them, and then sending them out. And also, the mixnet actually is able to scale quite rapidly as well, but that's something I'll get into in a second. And comparing the mixnet on a very high level to kind of the existing solutions that we have with VPNs and Tor, then you can see that a VPN, obviously, your VPN provider is able to know what you're sending and where you're sending it from. It's not particularly great. You have to trust that they're not kind of keeping logs. You have to trust they're not telling anyone. And you also have to trust that no one is going to lean on them and say, hey, tell us about all of your users, right? Which is obviously not in any way a particularly good situation to be dealing with. Tor does have multiple encryption, multiple packet hopping, right? But one of the downsides of that is that if for instance, I send a couple of cryptocurrency transactions through the same Tor circuit, then anyone who's able to actually kind of watch the network as a whole, this idea of a global passive adversary who can watch all the ins and outs, you're still able to probably make an inference like, okay, well, that's the same person who maybe sent those two transactions through the same Tor circuit. With NIM, each packet is actually routed individually. So as well as all of the formatting has gone slightly wrong with that diagram, apologies for that, as well as obviously all of the stuff I just talked about, the fact that all the packets are encrypted to look exactly the same. You have cover traffic, so you have maintaining this this kind of signal to noise ratio, which makes it very difficult to actually see, okay, well, there's more activity maybe happening now, there's more packets traveling through, what inference can we make from that? Maybe the inference of what time zone you live in, or what particular kind of service you might be talking to, or who you might be talking to. Each packet's actually routed individually as well. So you don't have this problem where you could kind of, send a couple of things through the same circuit, and then you can make a link like, oh, okay, well, there's traffic coming in there and leaving there along the same path, right? And so this is kind of a deep dive. This is kind of a summation of everything that I just said. So we kind of, let's follow the traffic all the way through. We have me on the left-hand side. I want to send hello to any of you. I will just send kind of normal packets to the NIM client, which is running on my machine, which is kind of just a code process which accepts all of this traffic, chops it up into these identically sized, identically encrypted Sphinx packets. It orders them, and it then routes each of these through the mixnet according to each 3 hop. So it will send it to a gateway, which is our version basically of essentially kind of a mailbox for clients that go offline. It's not particularly important right here, but that's what it is. And it will then go through the first mix node. The first mix node will then unwrap one of those layers of encryption. It will know where to route it to. It'll hold it for a variable amount of time, and then it will kind of mix it within all of the other either real traffic or cover traffic that it's also being told to route to other mix nodes. And obviously the mix node itself doesn't actually know what's real and what's not, or what's a dummy and what's not. And I mentioned earlier that the mixnet is scalable. So kind of underneath this mixnet diagram there, you can see that we have the mix nodes waiting to join the network. And what this means is that the mixnet is organized temporally into what we call epochs. And that means once an hour, the amount of traffic that's going through the mixnet is looked at. Maybe we need to bring more NIX nodes in to deal with this increased load. Or maybe we need to drop mix nodes out, because actually we don't need as many mix nodes mixing packets between themselves, right? And so once an epoch, maybe if the need arose, we could bring in these kind of mix nodes that have been waiting in reserve to handle this extra traffic, or we could drop some of them out. And then your data will come out of the other side. These packets are still coming out of the other side of the mixnet in this completely anonymized format and still within this stream of cover traffic. So the kind of inferences that you can make with kind of website fingerprinting or traffic analysis attacks become a lot more difficult. And then on the other side, it will either go to an app and a service, or, which is something that I'm going to talk about a little bit later but want to explore, maybe it's actually just a P2P kind of system which is actually held completely within NIM, and then it would just go to your client, and then your client could maybe talk back to me, right? But that's how traffic moves through NIM, and that's how we're enabled to give the kind of privacy-preserving properties that we can. I mentioned earlier the mixnet is incentivized, and to incentivize something, you need a token, a currency of some sort. So this is where we have the NIM token. And the NIM token is also one of the key aspects of the network, which means that we can be somewhat Sybil resistant, but that we can also have a reputation system over time. Because, as I mentioned here, every hour, whether a mix node is actually mixing or not is up for debate. So we need a way of choosing which mix nodes to actually include and have them mixing traffic. And we do that based on a reputation system, which is what the NIM token allows us to do. So if I want to run a mix node, I first have to provide a small bit of stake myself when I'm actually kind of bonding into the network and announcing myself to the network as being available to route packets through, right? And users can also delegate their stake to mix nodes that they want to support, and they could want to support a mix node for multiple reasons, which I'll go into in a sec. But this amount of delegated stake also is also part of the formula that's used every epoch to decide whether a mix node is going to mix and be involved in the active set or not. One of the other things that this allows us to do as well is to actually incentivize proper decentralization, not just on a architectural level, but also on a jurisdictional level. Obviously, if you could have a load of mix nodes that were all running really well, they had a very high throughput, but if they were all based in one jurisdiction, and then suddenly the ability to run that mix node was taken away from them, that obviously is a massive problem for the network. So if I, as a user, want to incentivize a mix node that maybe there's not too many of them in this jurisdiction, but I would like them to actually be able to earn from running this service and also bolster the whole mixnet by providing a more kind of jurisdictionally decentralized mixnet, my delegated staking is actually a method that I can try and achieve that. And there's a whole host of stuff that mixed node operators, we've already seen them doing. So they offer a certain cut of their, we call it mix mining rewards to their users. We've also seen people saying, okay, well, they will, people should delegate to their mixed node. They'll donate X amount of their rewards to particular causes, particular, kind of charities, whatever. So it's kind of this is essentially the token allows us to do all of this, and this is the kind of thing that you need both for Sybil defense, in that it makes it a lot harder to, if I want to spin up 1,000 mix nodes and suddenly start mixing, I would need to be able to have the minimum stake to actually do that, but then because these mix nodes don't have any reputation really in the system as well, then they're far less likely to be chosen. So this is how we defend against the kind of Sybil attacks or sudden increases in malicious actors running nodes that other networks are maybe susceptible to. I kind of just did that slide without actually clicking it. So yeah, this is the crypto economics of that slide, basically. The third part of the solution as well is our credentialing scheme. So everything I've been talking about up until this point, this is really how to protect from metadata leakage really at the network level. And this is something that, even if you're sending a fully shielded transaction, or you're sending a signal message, something like this, if you don't have this level of protection at the network layer, you're still leaking metadata. You can still start to be maybe de-anonymized by people who can run the kind of machine learning processing that governments and increasingly companies can also run, right? The credentials is a step up. This is when we're talking about, okay, how do you actually start providing the kind of unlinkability, that we're trying to provide on the network layer. And this really can be a system that you can use for anything, but we're really seeing it immediately as being an anonymous proof of X, a kind of an access token that you can use instead of a login, right? So this obviously is useful for private transactions. These tokens are, buying the tokens themselves is unlinkable. It can't be linked back to you. This is done, this is distributed between our validator set, which I'll talk about in a second. But basically, there's no single entity that can actually ever say, okay, well, Max tried to get one of these credentials from me for X, right? The credentials themselves are re-randomizable. And what that means is that, say, if I am a service, or I'm just someone who's able to actually look at, say, some kind of a login system, maybe let's say for, I don't know, another VPN service or something like this, and I can see that 100 credentials have been used. Because of re-randomizability, I can't actually tell whether that's 100 individual people, or whether it's one person that's logged in 100 times, or anything in between, right? So you can use the same credential multiple times, but each time you're unlinking this use from the previous use, right? And what this enables primarily is also private financial transactions as well, because you can essentially do something using this credential as saying, hey, there's a proof that I've done something somewhere else, or that I have a particular, say, amount of tokens. This is also something you could use for token voting, right? And this is a credential that proves that, but is never actually linked maybe to the account that has those tokens. Maybe this is on a kind of a transparent blockchain, something like this. These are selective disclosure credentials as well. So what it means is that you can prove you are you without having to share everything about yourself. One of the proof of concepts that we did, which proves this really nicely, is we made a privacy-preserving COVID passport, right? Which basically, it was a QR code which you could scan. It said, yes, this person can pass through this point. Say you were trying to move between Schengen countries, and this was when they were checking that you were vaccinated. And it would work. It would say, yes, this person can move through this point, but it wouldn't say everything about you, which is what current passports, current KYC procedures, all of these things currently do, right? So essentially, these are application-level, unlinkable pseudonyms that are single-use but reusable at the base level. And like I said before, our validator set between themselves issues credentials using threshold signatures, and these are also, they're blind signed, they're re-randomizable, and ultimately these are very generic, right? So these credentials, on a deeper level, what they do is instead of being an identity credential, saying this is who I am, it says this person, the bearer of this token, has the right to do X, to log into something, to pass through something, to maybe take a vote, But it doesn't say anything about who you actually are. And obviously, to do all of this, to have the token, to have smart contracts, to issue these credentials in a decentralized and trustless manner, you need a blockchain. Our blockchain is called Nix. It's called Nix to differentiate it from Nim, but also Nix is the Greek god of night. It's just a very cool sounding name as well. It's a Cosmos SDK chain, so it's IBC enabled, which means that then anything that happens on the Nix chain, for instance, maybe Coconut credential generation, could then, through IBC, the inter-blockchain communication protocol, be able to be done by the entire Cosmos ecosystem without the need to build bridges, right? Which obviously we've seen over the past year. Bridges can be susceptible to hacks. They're single points of failure for communication between different protocols. The fact that we're based on the Cosmos SDK means that anything we can do on Coconut, we can do on Cosmos, and people are already working on a Cosmos to Polkadot.ibc. So, you know, this is in terms of kind of the speed of adoption and also the spread of uses, basically, then the fact that we're Cosmos SDK means, you know, anything we do, we can then spread it to a load of people without having to worry about bridge hacks, different protocols, all of this kind of stuff. And we were quite quiet about this during our testnets as well. You know, our smart contracting framework, which is COS and WASM, means that we can write our smart contracts in Rust, which obviously makes them very safe, and then they can be uploaded to the blockchain as WASM blobs. And you know, these smart contracts were keeping track of, I think, at 1.6 thousand mixed nodes in one of our test nets. It was keeping track of all of the gateways, the stake, and the rewarding for all of these things. So these, you know, this is a very robust smart contracting framework that we're basically using in place of, you know, something like a central directory or a series of directory authority servers that something like Tor has. So I've just hit you with a lot of information about our architecture. This is a token and data flow. So you can see that our architecture is very complicated. It's needed to actually make all of this stuff work, but it has been working for quite a while at this point. I'm also aware of time, so I've already gone over this, and I'll kind of skip, and we can do Q&A afterwards if you have any questions about particular aspects of the system. So, obviously, I've just said all of that about our architecture. The question then is, how do you use it? And there are a couple of different scenarios, or a couple of different ways in which people would want to integrate applications with the mixnet, and we kind of have a different client for each occasion. So we have a WebSocket client. This is like a standalone process that you could just run on a box and just pipe data through, and it will send it through the mixnet for you. But say if you want to do something, you know, with a browser application, or you want to do something like edge computing, then our WebAssembly client would make more sense. This is, you know, it's packaged and distributed via NPM, like any other NPM package, and it's TypeScript that then is able through the magic of WebAssembly kind of call Rust code as well. And obviously this is a tiny, lightweight thing that you could put in any browser or edge computing kind of app. And then the final client that we have, which is the easiest way for people to integrate with NIM and the mixnet at the moment, which I'm going to kind of focus on for this talk, is our SOCKS 5 client. So say if you have an existing application that is able to support the SOCKS 5 proxy protocol, and this is, you know, the majority of good desktop applications now. This is Signal, this is crypto wallets, this is most browsers, right? You can just use our SOCKS 5 client to, without any code changes, kind of plug all of your application traffic into NIM and use that as your transport layer. So how do you do it? There's three things that you kind of need to do this, and at this point I'll kind of start jumping between this explanation and the network architecture slides as well. So obviously you need an application to proxy. You need an app that actually has support for the SOCKS 5 protocol, so Signal, Telegram, most crypto wallets, email clients, browsers. This comes fairly standard now. And then you just locally are also running an instance of the SOCKS 5 client. And what this is doing is it's just listening on a local host port for any traffic that you send to it, and it will do exactly what we said before. It will take that application traffic, so the U in this case might be your local Signal app, send packets to it, it encrypts them, it numbers them, and it encrypts them according to the route that each packet's going to take through the mixnet, remember? It then numbers them so they can be reassembled on the other side by the receiving client. It slots them into this kind of flow of dummy traffic that's also happening, so you can imagine dropping something in a very fast stream. And then it's routed through the mixnet. And then on the other side, you have a service. And in this instance, you would have an instance of a service, which is number 3, which is called the network requester. So this is just a service that you could run on a VPS, you could run on any kind of box, you could run it on a Raspberry Pi. And what this basically is it's just a piece of code which is listening for incoming traffic from the mixnet, and it will unencrypt that, and then basically unpack it, and that is whatever, some kind of a network request to an outbound service in the kind of clear net where prying eyes can see it. So this is something, basically kind of a proxy pass that sits on the other side of the mixnet. So even the network requester doesn't actually know where this, where this traffic came from. That it also has no idea. It will make a network request for you, maybe to Signal's backend servers. It'll take the response. And then with the magic of SERBs, so single-use reply blocks, it will actually be able to route that request back to you, and then, yeah, you'll be able to see that you have some new messages from Signal, right? So these are the three things that you basically need that at the moment are both very easy to set up, and that we have increasingly, I think we have about 50 different instances running at the moment as well, so that people can use different apps through NIM. And yeah, basically, this is the, I don't think these are running, unfortunately. So these were GIFs showing how you can just quite simply, with Keybase, the Electrum Bitcoin wallet, and the Blockstream wallet, actually be sending transactions through the mixnet as well, but these GIFs don't seem to be running, so I'll kind of skip them. That's obviously very developer-focused. There's some CLI work that's in there as well. But say if you're just you're a normal user, or maybe you just don't want to really mess around with the CLI to start using NIM, you can use our an application that we have in beta. Oh no, have the slides gone down? I'll hold off for a sec, just to see if the projector can come back. Yeah, maybe we could start doing Q&A now until the screen comes back up. That might be a good use of time.
Hi, Max. This is exciting. So, two questions. Have you thought a little or very much of the potential applications? And the second question is specific application survey and voting. Explain, please, how voting systems would benefit from routing through the mixnet.
Okay. So, actually, wait. Okay. I'll quickly answer that, and then I'll just continue with this. So in terms of have we thought a lot about different applications that can use it? We have thought a lot. Obviously, I'm the developer relations guy, so I'm the person who tries to get everyone to build stuff on this. And there's some slides, excuse me, towards the end about the extra stuff that's actually already started to be built and the stuff that we'd like to see built. With regards to voting systems, then there's two ways to quickly answer that. If I wanted to send a vote transaction to a DAO, I wanted to route through the mixnet, then I'm kind of granting myself essentially kind of, I'm protected against metadata leakage that can be used to de-anonymize me, right, as a sender. But if you also wanted to use Coconut for it, what you could do is I could actually kind of make a Coconut credential that said, hey, I have X amount of a governance token, and then use the Coconut credential to vote. So they're never actually kind of like linking the me actually whatever, signing in or signing a transaction with a particular key. I would then just use a credential that shows that I have this key and I can actually make this action, but without actually doing it, right? So you're kind of breaking linkability on the application level as well. But now the screen's back. So yeah, this is NIM Connect. It's a kind of a beta, single, very easy to use, single button application, which at the moment supports Keybase, Electrum, and Telegram. And the next version, we also have Blockstream and a couple of other wallets as well, kind of integrated in this. So what this basically is, you open it up, you select the service that you want to connect to, you connect, and then you just proxy that application traffic to your to the local host port that it's listening on, and boom, you're using the mixnet. So to go to your question, there's a load of other projects that people have already started, that we've already started to see build and come out of the community. One of these things is cryptocurrency transaction broadcasters. So we have proof of concepts that people have already built for Ethereum, Monero, and Bitcoin transaction broadcasters. So if we go back to here, then instead of maybe sending a message from your local Signal instance through the mixnet to the Signal servers and getting a response back from your network requester, then you actually have a situation where you create and sign a transaction, you send it to your NIM client, it chops it up into all of the identically encrypted, identically sized Sphinx packets, routes it through the mixnet, And that would then go to a service at the other end that would then broadcast that to whatever Ethereum, Monero, Bitcoin nodes. And then if you have maybe some JSON RPC acceptance response that comes back, it routes it back to you. So again, you're able to broadcast these transactions without revealing basically anything about you on the network level. So when the transaction was broadcast, when the transaction was kind of signed and sent, or the IP address of where it's coming from, right? We also have something called NIM Drive, which came out of a hackathon last year, which is also someone's continuing to work on this as well. This is an encrypted and private file storage and Dropbox application, basically, for your own file service needs. So it routes all of your files and all the requests through the mixnet, and at the moment they're actually stored on IPFS, so there's no single point of failure with takedown as well. This has a really nice GUI, but obviously it also exposes a CLI under the hood as well. And then we have something called a non-drop, which was a specification that we wrote for the Kiev Tech Summit that happened last month, which is basically used for the anonymous uploading of sensitive information, right, such as evidence of war crimes, and doing this in kind of a verifiable way that can be used, but then obviously protects the people who are actually uploading this stuff, right? And like I said, I'm DevRel. I want to get people to build on NIM, and one of the other ways I can do that, as well as from kind of building stuff myself, doing support and doing talks, is our developer grant scheme. And this is going to be coming very soon, hopefully like very, very soon in the next couple of weeks. There will be some specs that we're basically writing that we would like to see people building, so kind of starting to bulk out the tooling and the services that we want to see. You know, I've already mentioned that you could have a network requester for email clients, basically, and then you can actually, you know, you could route something like your local Thunderbird client. You could actually route that through the mixnet, so none of your email server backends know who and where you are, right? Obviously, one of the original use cases for mixnets as well was anonymous emailing. These community projects that I was already talking about, these are also being, you know, we're funding these people to actually work on this stuff as well. And we're also making an integration wildcard, which is kind of where I'm going to leave it before I pass over to Harry. So if you have an app that you think you would want to start connecting to NIM, probably with the SOX 5 client, but maybe with one of our others, then get in touch. And this is a wildcard really for developers and existing services who want to, you know, integrate their app and set up like a more privacy-enhanced service to protect the network level traffic of their users too. One of these big things would be, it would be great to also see a Monero wallet. And so just to kind of reiterate as well, the two things that you would have to build to do that would be, you would have to have this wallet SOX 5 connection on your local machine to send traffic into the mixnet. And then on the other side, you would need a network requester of some kind that was able to actually support the endpoints and the kind of formatting that this Monero wallet's using. So that was just kind of a bit of a more deliberate shout out regarding what we'd like to see built. And with that, I will pass over to Harry.
Cool, and we'll find some time for some Q&A.
Yeah, we'll also all be here, so you can grab us after the conference.
All right.
Okay, so I'm Harry. I gave, as Exiled Surfer, one of our oldest supporters, noticed, I gave a talk here, a lightning talk. It was really funny. I really enjoyed giving that lightning talk. And it was an honor to have Jim Bell and Adam back and friends in the audience. And Adam was like, I was like, should we do this? Because at that point, we were a research grant. We weren't really like building it for people to actually use. And Adam was like, yeah, you should. I was like, cool. You know, we can use mixing for more proof of work for more than just Merkle puzzles. So we just had a team meeting. First, I'll just go quickly through what we've accomplished and then what's going to happen in the future, because this is not super clear. So again, way back in the day, you know, we launched a testnet, got a bunch of sketch balls like Binance to give us some money. That was cool. We launched our testnet actually at the Chaos Computer Congress. At that point, we were running on Liquid. which we still are building a bridge to. Then we basically launched 2 other test nets, recode everything in Rust. We took, Amir and other people have built some like really early wallets and demos, but we really tried to build a comprehensive Rust-based code base. And then, COVID hit, we're all stuck inside, terrorized by our own governments, and that's a good time to code. So we basically finished off a lot of the work that was done that Max has been demonstrating here. And then this year has really been devoted so far to really getting the kind of crypto economics right. So we released the MIT crypto economics paper, which was fine. We launched all the tokens and everything. Awesome. Got some basic stuff working, Blockstream Green, Telegram, still a little buggy. But we have a lot to do. And so I'm going to talk about what we're going to do over the next year and make 1 or 2 announcements. So this year, the main thing I want to point out to people is that the mixnet, you can set your route, you can set the mixing parameters, but by default, currently, it's not particularly anonymous. The reason it's not particularly anonymous is because how anonymous you are is based on sort of 2 things. It's based on how many other packets you're mixing with. So if very few people are using the network, then you're not very anonymous because your total anonymity set is not so huge. And how long you mix with other packets. So that's a parameter. It might be based on different kinds of traffic, how fast you want your instant message to be, how quickly you want your cryptocurrency transaction to be delivered. That's a very sketchy cryptocurrency transaction. You might want to mix it longer. So what's going to happen is we are working with our scientists, Claudia Diaz, Anya Petrowska, and many other people, to really nail that parameterization down so that right now we'll launch the mixnet. The website will turn green. We hope this happens pretty soon. We're going to launch the website, a new website, and we say, hey guys, the mixnet, it's out of testing, it's ready to go. But before, we're going to probably spend about a month or 2, hopefully starting November 5th, because all good things start on the 5th of November, to effectively help people test the mixnet and help us get some parameters going that we think provide good amounts of cover traffic, reasonable latency, and all of that. So just so you know, it's still very much in testing. Don't risk your life using the mixnet yet. We aim for that at least by end of the year, and we'll try to also decentralize the governance, because right now it is kind of run not as decentralized as we would want. And then next year, if you've used the mixnet, you'll notice some things. It doesn't take advantage of multi-core. It's a bit slow. So we gave out a bunch of grants after we raised our last bit of money to speed the living daylights out of our system. We have Daniel Bernstein working on optimizing the packet format. Chelsea Manning, who hopefully will get here to come here next year, working on on optimized secure hardware. And eventually we'll get it in more and more apps. And our goal, so if anyone's been noticing, there's a wonderful feminist revolution happening in Iran with Jin, Jian, Azadi, woman, life, freedom. And what we know is we're trying to use NIM, and NIM is being censored in Iran. Our Chinese users have noticed that we are currently being censored in China. And of course we're being censored because we're doing all this crazy mixing and cover traffic. It really doesn't look like a normal internet connection. So the big focus for next year is not only speeding up, but adding anti-censorship features, obfuscation, so on and so forth to the network. So that we're going to be, so if you like, why should I run a mixnet? It's already 500 mix nodes, I'm missing out. Don't worry, we're going to be launching an anti-censorship gateway campaign later this year, early next year, to really focus on allowing people to use NIM, not just on this kind of, I would say, fairly clunky per app basis, which we're using to test and parameterize, but actually to use it, hopefully, if we can get everything fast as possible, speed up those Diffie-Hellmans as a VPN. And now, and the other thing we've noticed, which I assume everyone here has noticed, is essentially there's been a pushback by increasing numbers of governments, Korea, Japan, and now the United States with their attack on Tornado Cash, putting them on the OFAC list. Netherlands putting Alex in jail and like auctioning his private property while he's in jail without charges. So there's obviously a lot of trouble coming for privacy. That this may be the last year where people here aren't facing tremendous amounts of repression. So I want us to all stand in solidarity with Alex, which I hope people here are in solidarity with him. And we need a common legal defense fund and a common legal analysis of the threats so that we all can fight back when we get court orders or when the police come knocking on our doors, because no cypherpunk should be left behind. And so what we've done is we've teamed up with all of the privacy projects, at least the ones we get on in a chat channel. So this would be Aztec, Orchid, Railgun, Shade, Anoma, MobileCoin, there's a few, Manta, and we're going to launch something officially at DevCon in Columbia called the Universal Privacy Alliance. So if anyone here is interested, I think we even have, we have all sorts of crazy people in the chat room. We're interested in getting more people together because we need to get a common legal framework together so we know how to fight back in an intelligent manner. And we have the former Gitmo lawyer, Ahmed Kapoor, who also did the first challenge to mass surveillance by the NSA, leading the legal efforts there. So NIM, we're trying to become more, we are, again, just starting. It's really wonderful to have the community, people that have been helping us for years here. We're very proud to be showing off our progress. Next year, when we come back here, we hope to really have NIM ready for prime time and on everyone's fucking machines and fighting back against anyone that tries to stop us from having a right to be anonymous on the internet. So thank you very much, and let's get Q&A.
This is the stunning and intoxicating, side of this house, is actually knowing people that are working on solving world events, like, mentioning what's going on in Iran right now and having Chelsea on the team and everything. I want to reference Paul's talk about winning. We are incredibly powerful in this house, in our values, in our technology, and in our knowledge. And it's just really amazing to be involved with this stuff. So
yeah, I just want to say, one of the reasons I think they hit Tornado Cash hard, because it's one of the few privacy projects that people are actually using. But as the technology built here gets more and more powerful, we're going to have more and more, it's like more money, more problems, right? So we need to get everyone here to work together. I've seen people here that have been working with us. Scott Byman helping NIM out 2017, Amir Taki and the whole Darkfire squad helping us in 2018. We've got a lot of amazing people, so we need to bring these people together and really build this out. And next year is going to be critical, because that's when the hammer is going to starting to fall on this community.
So here's the first question that I'd like to ask, and then I'll open it up to the audience. So when we get to the level of COSM-WASM and having smart contracts that are not visible moving through the network, how do you guys see that as where's the threat vector once it is that we've moved deeply into COSM-WASM and self-compiling contracts that are not really visible across the network?
Okay. Okay. So to clarify the moment, that basically the COSM-WASM contracts themselves, right, are actually visible because our infrastructure is actually transparent, right? So actually, the traffic, the users themselves are the aim is to completely anonymize the traffic and the users, but then you have a transparent infrastructure layer, which is actually also partially a defense against kind of people giving you bad information about what's happening on the network layer, right? So you have you could have transactions that are anonymized and creating these credentials that you can then use everywhere else, but the thing that's actually the contracts that's doing them and the contracts that are holding the state of the mixnet they're not opaque, right? So they're transparent, because then you actually have a thing where you have transparency for the, kind of the powerful, should we say, the people who are actually running this infrastructure, and all the people who want to use it can then actually be very sure that what they're being told is actually the truth about the state of the network itself.
Yeah, so the theory is that there are some things transparency is good for, like the Fed is opaque, Bank of England's opaque, right? That's the whole point of Bitcoin. We got 21 million Bitcoin. We're not going to print any goddamn more Bitcoin, right? So we have transparent smart contracts, transparent chain, which then builds off-chain these anonymous credentials. The anonymous credential movement is off-chain. What does this look like? It looks a lot like Fedimint, actually. It's actually very similar design to Fedimint. We use the Stern Poncheval, Coconut, which is a different signature scheme, but the anonymous credentials are not necessarily like stored on chain, right? Like, you know, they're basically pushed off chain, and we just do some protection on chain and the contracts on chain. That being said, there are projects working on privacy enhanced smart contracts. I've seen Aleo, I think, is working on them. I believe DarkFi will hopefully be the first to push them out. You know, Ariel Gabazon, the most base cryptographer in the world, will probably push something out cool in ASDOC. So we do support more work on privacy enhanced smart contracts, but we're just talking about stuff that works right now, like today has been working for about a year, and those are all transparent.
Cool. So let's do this.
Thanks. So I'm kind of one pattern it seems like with apps that are popular now is that most of them are free. When it comes to things that people actually use. Obviously, if someone's using a crypto wallet, they're spending money already, and so they might be amenable to a fee. But Tor is free, Signal is free. What are the structures that could let users use NIM for free? Either where the wallet provider or light wallet node is taking a small fee and then buying the NIM tokens themselves, or where users are something like that. And then if they're paying, is there a way that they can pay in a recurring monthly way, the way they would currently pay for a VPN, instead of having to worry about topping up all the time?
So everyone here, I think, is some sort of crazed Hayekian. So as you know, nothing is for free in this world. There's nothing free in this world, you know, white weddings, so forth and so on. So the simple model, which is, you know, I would pay something to use a network, just so I pay a transaction fee. The anonymous credentials, why do we have the Coconut anonymous credentials there? It's just so you don't dox yourself like when using the network. Okay, that's one main reason. However, they're very powerful. So maybe your app should be free, right? Your app is free. Currently, everything's free because we're still testing. And let's say I'm Brave, right? I have some money somehow through my sketchy BAT network or whatever. So I would basically say, hey, NIM, all these users that are coming in, they're accessing Brave through our network, we're just going to like prepay for them. And all that traffic would be free. And on the back end, essentially the way to think about it is that Brave would just have like a giant anonymous credential that would pay for their users, and they would hand out a little kind of micro license, which is also anonymous, unlinkable, to the gateways and to the mixnet, therefore the mixnet itself, for each of those users. So we can see if they kind of spend too much or spend less. If they spend less, they can keep the extra bandwidth for like the next month. Same with VPNs, right? For VPNs, you'd probably pay up front, but let's say, you know, we want to have free VPN usage in Iran. So for example, you know, NIM Foundation, which doesn't even exist, or EFF or whatever, could just say, okay, we're going to say everyone in Iran comes through for free. Of course, someone's going to pay the goddamn mixed nodes. So how we handle that is we would just say, well, it's not really free, but we would kind of sponsor all the traffic coming in through Iran, coming in through this set of gateways, which has the, you know, anti-censorship features used by Iranian users. We think that's actually probably, I believe the majority of traffic to a network will be like that, right? So the apps today on the internet, they're not free. They appear to be free because they're based on surveillance. They're based on essentially capturing your data, you know, and then targeting you. And then, you know, who knows, selling something to you or drone striking you, depending on who you are. So we want to switch the whole capitalist model of the internet so that people do pay, but people that can't pay, other people can pay for them. And that is what the anonymous credentials do allow. That's why we build all this crazy machinery in the background.
So there's some fantastic thought that's gone into what you're doing, and clearly your values are absolutely in the right place. But I'm thinking about the sort of potential threat models and so on. I'm seeing your slides, and there's a piece on the one slide there that, for example, says, oh, we raised sort of X million dollars from A16Z, and that's fantastic for moving things forward. But these things, they always come with strings. They always come with obligations. They always come with, you know, they're not free. Nothing's free, including that kind of money. And so if that's built into the DNA of what you're building early on, and the obligations that come with that, and the restrictions and constraints that come with that, I hear you again saying wonderful things about opening up the governance and so on and so forth. How do you balance the threat from that? How do you legitimately handle those obligations whilst building the kind of network that you and we really want to see unencumbered by whatever that might be?
Yeah, I mean, the great thing about, tokens, and we have a prospectus, debt security, blah, 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 for ours, is that they don't come with that many obligations, right? So normally, if you're on a government grant, you have a lot of obligations to the government. Tor has that Rabbi Thomas from Team Simru, who's like basically doxing the whole internet, on their board. We don't have to do any of that, right? But we do need money. We want real money because we gotta have real coders to build the software. We tried building it with some volunteers, and it was a fucking disaster, just to be honest. I can't, it was like, I might as well just running a mental hospital, right? So I'm not doing that anymore. And so what we decided to do is we're gonna form this as a real company, and that does require funding, and the lightest weight, the least responsibility that we have is to basically give a bunch of VCs tokens. Easy. Now, of course, you do have Polychain, Andreessen, Binance, a bunch of random dudes involved, and they do have a lot. So they're going to be running and staking mixed nodes and getting that inflation, making some money. But I think that's kind of honestly okay, because the thing is, no single party can control enough of the mixnet because the packets are independently routed, and we basically put the mixed nodes ran by, for example, Andreessen in one layer that they can't actually de-anonymize anyone, right? So as far as I'm concerned, if we can get Andreessen to basically fund our software devs and then run a bunch of mixed nodes to provide anonymous service for people, that's great. It's actually a win. And the responsibility we have to all of them is about as low as I've ever seen, and I've done a few different deals before. I've used to deal in equity and whatnot, that we've seen in any other deal structuring. So I think it's much superior, much more money, and much superior to government grants. But there's an open debate between us and Tor and other projects.
So we have just a few minutes here before the next session starts. Max, thank you so much, Harry, for that. Max, do you have any closing things that you want to say about the Dev Grant program or anything like that?
Only closing marks is really reiterating, if anything that I said, or if you think that I missed something and that you think you would want to see either from any of the projects that are here, that you want to start using them as soon as possible, I want to start proof of concepting something, just please come and find me. I'll be here for the rest of the conference, or you can just email me, which is just max@nimtag.net, and get in touch like that. That's all. And yeah, hopefully I see a lot of familiar faces applying. Yeah.
Thank you so much, you guys. Amazing.